Okay, Bismillahirrahmanirrahim. Okay, folks, welcome back to another exam paper. Okay, as promised in the earlier video, we got now Edexcel GCSE Mathematics, a paper 2, the calculator allowed, the higher tier, the 1 MAO syllabus. That's the second paper. Okay, right, should we put up, please? Okay, right. Up a bit more. Right. Okay, first of all, question number 1, let's get started. Okay, today I'm joined by my student Isa and Somia. Question number 1. So A, B, C and D, E, F are parallel lines. So these are parallel lines, and that is indicated by these two arrows. If they didn't say it, then those arrows indicate that they're parallel. It says angle GEF is 47 degrees, GEF is 47. Work out the sides of the angle marked X, give reasons for your answer. Okay, right. If this angle is 47, first of all we should work out this angle here, because these two are called corresponding angles. Okay, please do not write an examination F angles, you will not get the mark. Okay, so I'll show you here where the corresponding angles are. Okay, so in school, not a school, they say you got an F angle. There's the F, which is facing backwards, but the correct terminology and the correct wording for the F angle is corresponding angles. So this one and that one are in the same position, they correspond to each other. Right, so if we work out E, we'll know X. So let's work out E. What do we know about the characteristics of this straight line here? So we have a straight line, and we have angles about a straight line. So the two angles, Isa, what do they add up to? 180. Thank you. That's 47. 47 at E. Okay. You'll be writing your working out down here in the examination paper. I'm going to write mine up here because it's easy for me to up here. So please make sure you do yours on the bottom, okay? Okay, folks? Ready? So we say 47 at E is equal to 180 degrees. Why is that? The reason for that is angles at a point add up to 180 degrees. Angle at a point. Angles at a point. Okay, a little bit we're going to add in here. On a straight line. Okay. So these two angles are at the same point and they're on a straight line. So we're just considering that part of it. So they will add it to 180. That's the reason for the hour rule there. So let's just write down again over here. Okay, we need to work out the value of E. So to work out the value of E, Isa, what do? We look at the E, and what's been done to the E is been added by 47. And opposite of add by 47 is? Minus 47. So E will give us an answer of 180 minus 47, which will give you 133. Okay? Okay, so that's 30, 70, and that will give you another 10, that'll give you 180. Okay, so we know now that E is equal to 180. Sorry, E is equal to, pardon me, E is equal to 130 degrees. If E is equal to 130, what's X equal to?
50.
The same, because they're corresponding. So E is 130, so what we say here now, say X is equal to E is equal to 130 degrees.
133 degrees.
Pardon me, I said that earlier, Smir. Okay. Okay, I've got the projected line in my face. Yes. Right, 133 degrees. So this angle is equal to this angle, which is equal to 133. And the reason for that is? Reason, because it goes there, give reasons for your answer. So you're making statements and reasons. So corresponding angles are equal. Okay. Statement, we made a mathematical statement and a statement in terms of English, declaring what the situation is, solving it. So E is equal to 133, not 130. Okay, E is equal to 133 degrees, which is the same as angle X, because the corresponding angles are equal. Right, okay, let's move on to the next question. Okay. You got to use your calculator to work out 38.5 times by 14.2 divided by 18.4 minus 5.9. Okay, right. Let's get the calculator. Let's see what we get here. So I'm going to use on this calculator the Casio FX85 GT, the fraction button. Type in the top on the top. 38.5 times by 14.2. Press replay, it brings it to the bottom. We've got 18.4 minus 5.9. Press equal. That gives us 43.736. Is that what you got, Isa? 43.736 on your calculation? Okay, so we get here. It says that you must give your answer as a decimal, write on all the figures in your calculator display. So we get here 43.736. Now it says write your answer to part A correct to one significant figure. Now, what is a significant figure? Your first significant figure is your first figure of significance, first non-zero digit. So this here actually is your first significant figure. Okay, let's put this calculator down. Right. Is that the right numbers here?
Yeah.
Okay, right, here we go. So here we have. Okay, this is our first significant figure, first SF. Okay, so unlike decimal place, which is always on the right hand as the decimal point, significant figures can be wherever the first non-zero digit is. So here's actually in the tens column. So we look at the next number. We call this number the decider number. Okay, so this number, okay, tells us whether we're going to round it up or not. So that's our last digit, decider. Now if the number is 5, is it less than 5, we leave it alone. So this number 3 is less than 5, so we leave the 4 alone, we copy the 4 down. We must fill this gap here with a 0, and we stop at the decimal point. We don't have any of this number on there. So the number 43.736 to one significant figure gives us a total of 40. Okay? Are you happy with that? You say that you got?
Yeah.
Good lad. Okay. So 43.736 is 40 to one significant figure. Remember, when you're filling in, when you stop at the first significant figure, you have a gap until decimal point. You can't leave a number with a gap in it. You must fill it with a 0. But you must stop at the decimal point.
Yeah.
Okay? Good. Next question, please. It says that Pradeep wants to find out, so we have to do a bit of focusing on that. Okay, that's better. Okay, Pradeep wants to find out how much time people spend playing sport. He uses this question on a questionnaire. How much time do you spend playing sport? 0 to 1 hours, 1 to 2 hours, 3 to 4 hours. Okay. Write down 2 things wrong with this question. We can spot 3 things wrong with this question. For the sake of the students, we'll write 3 down, 1 in brackets. What's the first thing? It says how much time do you spend playing sport?
Times overlapping.
The times overlapping. So we got overlapping. So basically, if you say 1 hour, you can either put the answer in here or there, isn't it?
Yeah.
And if you have a 2 hour answer, that can only go in one place, but you got overlap here. That's not good. Okay, now, how much time do you spend playing sport, meaning per week, per year in your life? So they haven't given you a time.
Yeah.
Okay? Right. Okay, right. So they haven't given time frame, but they're asking you over. Okay, so overlapping time, no time frame. What else?
There's no option for over 4 hours.
That's right, so it's not exhaustive. Okay, so for the last answer we're doing a different colour. So there's no option for more than 4 hours.
Can you write the sample is too small?
Not the sample bit too small. The options are not exhaustive. It's called. Okay. So not exhaustive means that it doesn't cover all the possible answers that we could have had. Next question says design a better question for Pradeep's questionnaire to find out how much time people spend playing sport. Okay. Okay, now we said this. They didn't ask about the time, did they? So now put the time in there.
Yeah.
So what do you say? How long do you spend on sport in a week? So the time frame in there. Let's put some response boxes down. Okay. Okay, so we have 0 hours. Okay, let's get that down, folks. Got that down?
Yeah.
Okay, how long do you spend on sport in a week? So we've got the time frame, we've got the hours, there's no overlapping now, is there? You happy with that?
Yeah.
Okay. Alright. Okay, alright, let's move on. Next question, please, Sneha. Up a bit more, can't see the graph. Okay, right. Okay, let's just make this a bit smaller. Right. Okay. So on the grid, it says draw the graph of y is equal to 3x minus 2 for values of x from -1 to 3. Okay. Right. Okay, Smith, I'm going to write it down on the board over here on the side. Y is equal to 3x minus 2. Okay. Smith, can you enlarge it back to 100%, please? And take it up. Okay, take it up now, completely. Up. That's good. I'd rather have a bigger graph. That's nice and chunky. Okay, now you need to plot a straight line graph. How many points we need to plot to a straight line graph? We need
4.
2 points to make a straight line. Now,
They give you them here.
Okay.
Yeah, they give you the numbers.
Okay, they give us -1 to 3. That's right. Now, have they given us a table in the question?
No.
No.
Okay. I haven't given this table, we'll make a quick one ourselves. Right, here we go. Let's rip this one out from over here. Okay, we have X and Y. So if you want to do every point, it's not necessary if we do every single point. We'll just do quickly. So you got to go from the minus to the 1 to 3.
Yeah.
To do a straight line, we only need 2 points. Okay, we can do this here. To do each point, you only need to do more points when you do a curve. Okay, now, so we have here y is equal to, the graph is, y is equal to 3x minus 2. So if you start with minus 1, we put minus 1 into here. We have 3 times by minus 1, and then take away 2. 3 times by minus 1 is?
Minus 3.
Minus 3. And then we take away another 2 gives you?
Minus 5.
Minus 5. Let's do 0 next. You put 0 in there. Y is equal to 3 times by 0, take away 2. 3 times by nothing is nothing. And then we take away 2.
Minus 2.
So y is equal to minus 2. I'm going to do the last one now, the third one. So 3 times by 3, and then we minus 2. 3 times by 3 will give you 9. 9 minus 2 will give you 7. Okay, let's plot these points now. So the first one corresponding to minus 1 and minus 5. So here's minus 1. We've got to go down by minus 5, so you put across there. Then 0 is 0 along the x is minus 2 along the y. So here's 0 along the x, 0. Come down by minus 2. Put another cross. And the last one was 3, 7. So you've got to go up by 7. So across by 3 and up by 7. So that gives you 3 points, for example, for our question. And then we need a ruler. Okay. Okay, I'm trying to do the best I could with the technology at hand. That's that question done. So you should have a question that looks like that. Okay, is that all we need to do for that one?
Yeah.
That's all they asked us on the grid, draw the graph. That's lovely. Okay, let's move on to question number 5. Right, now question number 5, please. Is the phone working now? Okay, Mr. Weaver's garden is in the shape of a rectangle. Okay, the 5-star means it's one of our new functional skills question. Okay? That's what the star is telling us. So, this is the new style of question that they introduced in the paper. There's a patio, here's the patio, and 2 ponds in the shape of 2 circles. The rest of the garden is grass, so all the shaded part here is grass. Mr. Weaver is going to spread fertilizer over all the grass. 1 box of fertilizer will cover 25 meters square of grass. How many boxes does he need? Okay, right. Can we move this up a bit, please? Up a bit, up a bit more, bit more, and a bit more. That's the stop right there. Okay, first of all, we need to work out the area that we're dealing with. So let's have a look at. So we got 17 meters, and how much is this little bit over here?
2.8.
So we got 17 meters minus 2.8. That will give you this rectangular bit here, the one with the shade in it. So we want to completely cut out the patio part. Don't need that at all. So 17 minus 2.8, and that will give us now the length of the garden here. So they will call this part our length. And then we have our width. What's the width?
Width is 40.
Width is?
Oh, 9.5.
9.5. Okay. And then what we're going to do with that, once we work that out, we want to minus the area of the 2 ponds.
Yeah.
Okay. So we want to do minus the area of the pond times by 2, because there's 2 ponds. Now, in this particular circle over here, they've given you what measurements are. Is that the circumference? Is it the diameter or the radius? What measurement is that?
Radius.
That measurement that goes all the way across is the
Diameter.
diameter. But for our area formula, which is pi r squared, what do we need? We need the radius. You always put the radius calculation in. So let's have a look. Let's change colour. So we have pi. Pi, we'll do as 3.14, or use the calculator, pi time by the radius. Now 3.8 meters is the diameter. What is the radius? 1.9. Okay, so this calculation here, pi, this is pi time by the radius squared, and then we're going to multiply it by 2. Why are we going to multiply it by 2? You might say, why do you divide it by 2 then time by 2? To divide it by 2 is just so you know you're putting in the radius. The radius is always half the diameter. It just so happens that we have 2 of them, so we end up doubling it again. But I still want you to put in the radius value correctly. Okay, that is the correct radius. We're doubling because there's 2 of them, and not for any other reason apart from that. So let's copy the calculation on the bottom. So 17 minus 2.8 is the length. We multiply it by the width, 9.5, and then we're going to minus the area of the pi r squared. Pi r squared, okay, which is, let's put the values in, okay, we have 3.14 times by 1.9 squared, and we're going to have 2 of them. So that will give us the area. Okay, that will okay, so you need to put this into your calculator in one go, Isa, the whole lot.
Yeah.
These new calculators, the Casio ones, you can put in one go, it'll deal with it. So what do you get? What do you get? 17 minus 2.8 times by 9.5 minus 3.14. You should get an answer of. Come on, folks.
112.2292.
Question number?
Number 5.
112.2292.
2292.
Okay. Right, now, do you use 3.14? Do you use the pi button?
3.14.
You use the pi button. What do you get, Isa, on yours?
I haven't done the calculation.
You did it.
So do that.
Yeah, please.
112.2177.
Yeah, 100, what do you get? 112 point?
2177.
Yeah, 112.21. Okay. That's our answer so far. 112.217. What's the next number? 7.
2177.
Okay, now, that's how many meters squared of grass that we have. And we know that the grass, the fertilizer covers 25 meters of grass, 25 meters squared. So we have to find out how many of these will fit into there. So the next calculation involves this being divided. So we now need to do, so I hope you haven't got rid of your calculation from the calculator. What we're going to do now, we're going to reuse that number, 112.2177, and we're going to divide it by 25 to give us the number of bags. Right, what do you get when you get that, Isa? Quickly, come on. The purple calculation on the bottom. Okay, folks.
4.48870.
Okay, so Isa's getting 4.488, which is good. 4.488 bags. Okay, that's the raw calculation from the calculator. 4.488 bags, but can you buy in reality 0.488 of bag?
No.
So if you need that many bags, how many bags do you actually purchase? 5. Correct. So we actually got to purchase 5 bags. We got to round it up because we can't buy that much. Can't buy a fraction of a bag. We're just got to buy the next bag. Okay, we're happy with that calculation. The most important thing is the idea. Minus the length of the patio. Okay, then you got a length and a width. You work at the area of the rectangle. You work at the radius from here. You work at the area of one pond and double it. Okay, and then you minus that from the total area of the rectangle, and we've got our number of footage in terms of how much meters squared of grass we have, divided by 25, because one bag costs 25. That tells us that. We round it up, and that gives you 5 bags. Okay, lovely. Let's move on to the next question. Okay. Come on, Samantha, take it up, please. Okay, here's another start question, another functional maths question. Again, you start in the corner. Potatoes cost £9 for a 12.5 kilogram bag at a farm shop. The same one that's sold for that price. Okay, so £9. Okay, £9. Move. £9. 12.5 kilograms. We have 1. Okay. You done this one yet?
Yeah.
Good. Okay. Right. We need to work out which one of these is the better value for money. The first one is from the farm shop, yeah? And the second one is from the supermarket. So, we can either do it by cost per pound or by kilo. Both of them work same way.
Kilo.
You want to do by kilo? Okay, Mr. Isa is done it by the kilo. So I need to get from 12.5 kilos down to 1 kilo. Okay, that's 2.5 kilos. We can get down to
I've done 2.5 and down to 12.5.
Okay, so you got that down to 2.5?
No, I got 2.5 to 12.5.
Okay, that's another way of doing it. But the unitary way to do it is just get everything down to 1 kilo. Compare them. So you divide that by 12.5. That'll give you 1 kilo cost. So you divide that by 1.5. So what's 9 divided by 1.5? Work that out, please. This is called the unitary method. Yes, in this particular instance, 2.5 and 12.5. 12.5 is a multiple of 2.5, so that can be done in an easier way, which Isa just mentioned. I'm doing it the traditional way. So just in case in another exam question the numbers are not multiple, this is how you would do it. That your way is a quicker way in this particular question, but not in full. I'm giving you a general method that will help you in any situation. So we work out what 1 kilo is. So 2.5 down to 1 kilogram is divided by 2.5. Right, what do you get for this part here? 9 divided by 1.5, what do I give you? 6. So 6 pounds is equal to 1 kilogram. Okay, shh. I can hear you in the video. Can you stop here? Yes. Yeah, sorry, pardon me. Okay, sorry. I said divide 1.5. Pardon me, folks. Okay, divided by 12.5. What we divide on this side, we divide on this side. So, each side 9 divided by 12.5 in the calculator, please.
0.72.
0.72. Good. Okay. So, what will we do on this side? We got to do on this side. Okay. So we divide them both. Right now, 2.5 kilograms down to 1 kilogram. We divide it by itself. 2.5 divided by 2.5 is 1. 1.1 pound 83 divided by 2.5 will give us
0.732.
Okay, so 1 kilogram will cost you 72p, and 1 kilogram will cost you approximately 73 and a bit more p. So which one is the better value for money? The one that each kilo costs you less. So, okay, so we said best buy, or the language that they use, which is better value.
Farm.
So that's going to be the farm shop. Okay, folks. Right, are we happy with that?
Yeah.
Good. Let's move on. Right, let's have a look. Scatter graph shows some information, question number 7, about 8 cars. For each car it shows the engine size in litres and the distance in kilometres the car travels on 1 litre of petrol. Okay, for this we need to do a line of best fit. Okay, I don't have a see-through ruler, but you should really use a see-through ruler so you can get a good nice average line. And I'm going to put my average line on about 7 example there, try that. Okay. Right. So I've got a few below, and I've got going through that one and one above it. Okay, that's my line. Probably could slightly skew it down to the left hand side. Let's try it. Let's try using a see-through ruler. Maybe I can do a better line. The ruler's too small. Let's try it with a line. Okay. That looks like a better line, yeah? Okay, right. The scatter graph shows some information. We've done the line of best fit, which is, don't move it, don't move it. Can't move that. Right, let's have a look at the next question. What's it asking us? So we've done the first part.
What type of correlation does it show?
Okay. What type of correlation does the scatter graph show? Now, because it's called a
Negative correlation.
negative correlation means as one thing increases, the other one decreases, so it's going downwards. So negative correlations tend to be going that way. Positive correlation would be going that way. Okay. It says a different car of the same type has an engine size of 2.5 litres. Estimate the distance travelled on 1 litre of petrol by this car. Okay, now 2.5 litres. Let's change colour. Okay. 2.5 is 1, 2, 3, 4, 5. Okay, question number 7. And okay, what value have you got, Isa?
I didn't do it.
You haven't written the value yet?
No.
Okay.
Mine shows 11.2.
Okay, according to this we have 10, and then in the middle of this is going to be 11. So I'll go about, just say about 11.1. Did you got 11.2?
Yeah.
Lovely, what do you get?
Same.
Same, okay. And they want to know how many, what distance to travel, yes? So we're going to write over here. So the value over here on my scale is roughly 11.1 kilometers according to, if we start here and we go up, hit the line and go across. Okay, let's move on to the next question, folks. That's that question done, negative correlation. We're using the graph to work out the, right. Done. Let's move on. Okay, stop right there, stop. Take on a bit much in there, that's it. Lovely. Right, okay. It says rotate triangle A 90 degrees clockwise, center 0. Okay, now, for this, Isa, I would advise you to use some tracing paper, which I'm about to give you now. That is it. Okay, I'll show you how to do that. Oh, lovely, beautiful. Okay, Isa, let's have a look over here. Now, is this shape at the center, first of all? Is this shape at the center?
No.
No. So they want you to rotate about the center. What does that mean? They've actually rotated in the center, but it's not actually on the center. So how do you connect this shape with the center? What do you do with it?
You draw a line.
You draw a line with the nearest point, yeah? Thank you. Okay, so each side same we draw, I'll call this the rod. Okay, I'll call this the rod. We've got to join the shape from the closest point to the center. The rod. Okay. Now, it wants you to rotate the shape through 90 degrees clockwise. Okay, so right. Pass me the protractors, me. Okay, here we go. Grab that. Right. Does anybody know where 90 degrees clockwise is? So if you turn this 90 degrees clockwise, okay, one quick way of doing it, or easy way of doing it, think of this as a little rectangle here. Okay, if you rotate that rectangle 90 degrees clockwise, where would it be? Okay, so if you spun that rectangle around, it would be. Now, I want you to draw that line there and then double check it, measure it each side with your protractor. Measure it. So do that while it's done there. So you join the rod up. This. Okay, that's like a little rectangle here. You spin the rectangle around. Where do you put the rectangle up? And measure the angle. You can either put a protractor on here and measure 90 degrees and draw a line so you know where to stop, or you use this like little kind of little mini technique where you box off the rod and you rotate the little box with the rod in it, and that gives you that position. Nice. So do you get 90 degrees?
Yeah.
Okay. So two ways you can do it. You can either put a protractor on here and measure 90 degrees from there, so you know, for example, on this line here you're going to stop your rotation. Okay, now let's do it. Do you get your tracing paper?
Yeah.
I got my tracing paper. Okay, right. Let's trace them. Okay, so there's my shape with the tracing paper. Okay. Right. Right. So you said you got your things traced?
Yeah.
So we hold our shape there where the dot is, and we move it round until the rod matches up with the other rod over here, and then we stop. And we should get roughly over there. What we do now is pick up the tracing paper and we mark on the points and check it. Yeah, that matches. Pick it up, mark the point. Pick it up, mark the point. So we should get. It's messed up. That's me making the camera shake. Okay, let's have a look at that one. Let's just check that. So we started with the shape. We join the rod to the center. We don't rotate it. I'm using my finger now. We turn it around until it matches that. And yep, okay. So that's roughly there. Right. Make sure you put the dot in the corner over here, if you have there. And that dot's in that corner, that dot's in that corner. Okay. Right. Clockwise tells us the direction of the clock. You've got that, Isa, you understand that?
Yeah.
Okay, good. Measure that, 90 degrees. Okay. Right. Okay, that's the first question done. Okay, so can we take that shape up, please? Okay, the next question says enlarge triangle B by scale factor 3, center 1, 2. For this we will definitely need to use our ruler. Okay, now let's get the center and take a line from the center through each corner of the triangle as long as we can. Now let's try. So you're making the table shakes now. So it's not touching now, you can shake it. You can shake it. Okay. So you said you got your lines done?
Yeah.
Okay, my lines, okay, we've gone there. Right, it goes by scale factor of 3, center 1, 2, there's the center. Now, look at the distances. The distance from here to the first corner is how much? The distance is 2. So we've got 2, and we times it by 3. And that gives you 6. So this point here will now be at a position of 6. So 1, 2, 3, 4, 5, 6. That's that corner done. Okay, scale factor 3 times. Now this point here is 1, 2, 3, 4. 4 squares across. And now we're going to have 4 times by 3, that will give us 12. So this point here will now move to the position 12. So let's join them up. Do you mind freehand? Please make sure you use a ruler for yours. Okay. Now the next point here, we can measure this distance here and then times it by 3. What's an easier way? Okay, where's it going to go? The line's just going to go straight up. Okay. From this point here, that point is straight up. So we can, in a sense, take it straight up. Okay, I'm just thinking to myself, is our line slightly out because we should have 1, 2, 3 is the height here. And then we've got 3 times by 3 should give us a height of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, our line is slightly out. So the line should actually go to there. So the line that's drawn here on the board is slightly out by only by a fraction of a few millimeters. Hopefully your one, when you draw yours more accurately, so I'm using a magnetic ruler on the board and stuff, and slightly out, so the line should be going through that corner. So that's just double checking. Okay, so that's going to have a height of 9, and then you join that up, and then we have that shape. Okay, please make sure when you do your shape on your paper, obviously, because we've got some slight bit of movement and we've got the situation with the ruler and stuff. So we're going from here through that corner. My line slightly down by 1, 2 mil. Your line should actually go straight to the corner over here. Okay? You got that, Isa? You got yours going through the corner? Good? Yes, you cut it too much to the corner. So if you actually go there, you should. See? I didn't cut mine, but mine's went down slightly. Okay, in the examination, if your line is slightly bit down or slightly bit up, but you know that 3 times by 3 is line and the dot should go there, but your lines, for example, over here, where your line is, for example, a teeny bit lower than like mine, don't just follow your line, follow what the measurement is as well. So the measurement is 9, so put in the correct position. Okay, so don't let the line, get you in the wrong place. Okay, are we happy? Done? Okay, enlarge triangle B by scale factor 3, center 1, 2. So we've done that enlargement. Next question. Linda is going on holiday to the Czech Republic. Right, let's get rid of this. Okay. Okay. Where's my black one? Please have some more black. I left it with you. Okay, Linda's going to holiday to the Czech Republic. She needs to change some money into krona. She can only change the money into 100 krona notes. Linda only wants to change up to £200 into krona notes. She wants as many 100 krona notes as possible. The exchange rate is £1 is equal to 25.82 krona. How many 100 krona notes should she get? So, first of all, let's do that. Write down £200. We've got to multiply each pound by the conversion, which is 25.82. Okay. Right, and that will give you an answer of
5164. 5164.
5164.
164.
Okay, so 200 times by 25.82 will give you an answer of 5164. Question number 9. Okay, that's good. Now, that's how many coronas we have. Okay, now, we want to see in that total conversion how many hundreds notes are there. What do we do now? The next calculation will be 55164. We're going to divide it by 100. Okay, if we divide that by 100, the quickest way of doing that, there's no point, we'll be 2 places back. That gives you 51.64. Okay, 51.64. Alright. Okay, now the question says what is the greatest number of 100 notes? So what's the answer going to be? The calculation is giving us 51.64. Can you have 51.64 100 notes?
No.
So you can only have 51. You can only get 51, you haven't got enough for the 52nd one. So you wouldn't be rounding up, you actually be rounding it down to make this answer sensible. So how many 100 corner notes do you get? There's that many. You don't have enough for the next one. So we get 51. Okay, let's move on. Okay, number 10. M is an integer. Integer meaning whole numbers. Negative or positive, but whole numbers. Such that the inequality M is greater than -2 but less than or equal to 3. We can quickly show this in a number line. So here's -2, -1, 0, 1, 2, and 3. Okay, so the M must be greater than -2. So you put an empty circle. Okay, so now all the solutions are in the blue area. So -2 is not part of the answer because it's got to be greater than -2. Okay, but -1 is, 0 is, 1 is a whole number, 2 is a whole number, and 3, because 3 is a whole number and it's got an equal there, it's also part of the solution. So Isa, what do you write down over here then? We write down here, write down all the possible values of M.
-1.
So we start with -1. Okay, so -1, then
0.
Then 1, then
2.
2, and then
3.
3. Okay. The next question says solve 7x minus 9 is less than 3x plus 4. We treat the inequality as though it was an equal sign in terms of like a standard double-sided linear equation. Okay, so don't see the inequality and say, well, how do I deal with inequality? Deal with it in the same way that you deal with it in the same question as though an equal sign was there, the way you move x's from left to right and numbers to one side. In that sense, you treat it. Okay, so let's get the x's onto one side. So you saw what do we do with the smaller x? We start there, yes? We grab the 3x, take it to this side, becomes a?
Minus.
Okay, we grab the -9, take it to the other side, becomes a?
Plus.
So now we have 7x minus 3x. The inequality stays exactly as it is. Okay, and then we have on this side plus 4 plus 9. Okay, so 7x minus 3x will give us an answer of 4x. 4 add 9 will give us an answer of
13.
13. Now, we still have to move the multiple by 4, we haven't finished yet. We've got to work out x. So the opposite of time by 4 is
Divide.
divide by 4. So we say here that x is less than 13 divided by 4, and the answer you get is
3.25. 3.25.
Okay, Isa, what do you get for that one?
3.25.
Good. Okay, most students will look at the answer then say, oh, I've made a mistake because I got a decimal answer. Can't be decimal. This question is not like this one where they said they want integer values. That's not an integer value, but they haven't asked you for integer values. So don't confuse the criterion of this question with this one. In this question here, you can have a decimal answer, a negative decimal answer, a fractional answer, any type of answer is possible. But for that one you can't, because they said specifically we want integer values. Okay, right, let's move on to the next question. Okay, the equation x cubed has x cubed minus 6x is equal to 72 has a solution between 4 and 5. That's where we start. Okay, so let's write down x. We have x cubed minus 6x is equal to 72. That's what we want to get. So we start off with what they tell us first, which is 4 and 5. Okay, now what I need to do in the calculator is put this in. So where you see the x, put the 4 in there. So we got 4 cubed minus 6 times by 4, because 6x is 6 times by 4. Okay, let's see what we get for this. And then that one will be 5. X is 5. 5 cubed minus 6 times by x. X is 5. Okay, let's put that straight into your calculator and give me 2 answers please for that.
For the first one and 95 for the second one.
Isa, you got 40 for the first one?
Yeah.
And second one?
95.
95? Yeah. Okay, the number that we are looking for is what number?
72.
72. And we've got an answer of 40 and 95, so it's going to be in between those. Between 40 and 95, you have a difference of 55 numbers. Now 40 to 72 is about 32 numbers. Okay, so where should we start with the next part of the question? We need to go in between these two numbers. Should we start off roughly halfway?
Yeah.
Okay, so if we start roughly halfway, the second part of the calculation is going to be 4.5. So now can we do now 4.5 cubed minus 6 times by 4.5. Okay, let's work that out now.
64.125.
So we get 64.125.
0.125.
So we're getting closer. Now we need to choose a smaller number, Isa, or a bigger number. Because 4.5 gives you 64, we need it to be bigger number. So let's try now 4.6 into calculation. Okay, 4.6 cubed minus 6 times by 4.6.
69.736.
Okay, we're getting closer. 69.7.
36.
What number are we doing?
4.6 now. Okay, now Isa, should we go higher again? We're getting closer now.
Yeah.
One more. So let's try 4.7. Okay, so we do 4.7 cubed minus 6 times by 4.7. That gives an answer of
75.623.
75.62.
623.
Okay, now we need to work out of these two, 4.6 and 4.7, which one is the closest to 72, the closest one. Because the answer says they give you answer to one decimal place, so we can't actually go to 4.65 and 4.67. Do you understand?
Yeah.
We can't go to second decimal place because the question has restricted us here to one decimal place. So now we just got to work out by doing a difference calculation. Difference. So I would like you to do it now. 75.6362, if we take away 72, my target. Okay, what do you get? If you do 75.623 minus 72, that will give you an answer of?
3.623.
So this number here is plus 3.62 higher above the number. Now what I'd like you to do is, we need to do 72 minus that.
2.264.
So 72 minus this number. What will that give you?
2.264.
That'll give you 2.264.
64.
That's below it. Okay? Or if you just type in this number, type that number, it'll give you a negative number anyway.
Yeah.
So that's just telling you that it's in this instance, it means it's the numbers below. So out of these two numbers, which one's closer? So this one's 3.62 above, that one's 2.264 below.
Minus 2.
That one. So that one, this number here, which is the 4 points, that gives you the closest number to our answer. So for that reason, we have to say that x is equal to 4.6 to 1 decimal place. That is the closest we're going to get to our answer of 72. Okay. Isa, we got that? So you have to take them away to. Okay, let's have a look at the next question, please. You said, first of all, have you got that done yet?
Yeah, wait 2 seconds.
Okay, wait 2 seconds, man. Don't move yet. To get the marks, make sure you do originally the 4 value, then the 5 value, then your iterations, your little steps. Okay, try not to jump around. Try not to jump from 4.5 to 4.71 go, or do 4.2, then do 4.9, then do 4.1. Try to keep it nice and consistent in a pattern going towards it.
Done.
Are you done? Okay. The probability, question number 12, the probability that a biased dice will land on a 5 is 0.3. Megan is going to roll the dice 400 times. Work out an estimate for the number of times the dice will land on a 5. To do a calculation where you have a repetition that many times, we have our probability. And we multiply it by the number of times we repeat the experiment. Okay, so what's the probability, Isa? Probability is 0.3. And Samir, how many times if you repeat the experiment? How many times?
400 times.
400 times. So 0.3 times by 400 times will give you an answer of
120.
So 120 times out of the 400 you expect to get a number 5. Okay, we've done that?
Yeah.
Right, next question. Question number 13. Okay. Right, Isa, you happy with that?
Yeah.
So may I take that one a bit more up, please? Right, a bit more last there. Bob asked, question number 13, Bob asked each of 40 friends how many minutes they took to get to work. So we have a table here, minutes between 0 and 10. Well, less equal to 10, that's more than 10, less than 20. So you got your range here, okay? So we got frequency 3, 8, 11, 9 and 9 over here. Okay, that's our class width. Okay, that's your data, and it's called group data.
Yeah.
So we got group data from 0 to 10, more than 10 to 20, more than 20 to 30 and so on. Work out an estimate for the mean time. Okay, students here read the word estimate and they think we have to guess the answer. You do not guess the answer. Okay, estimate it means like what will be roughly according to the calculations allowed. So if we had a frequency table with just with discrete values here, it'd be nice and straightforward. We've got a range, so which value do we multiply by? So what do we need to do first? We need to make a little column here. Okay. And in that column, what we're going to put in there?
Class width.
We're gonna, not class width, midpoint.
Alright.
Yeah. So in here we're going to have the midpoint values. Okay. So midpoint between 0 and 10 is 5. Midpoint between 10 and 20 is
15.
Okay. I'm just going to make my box a bit thicker because it's going to start crashing. What do we say here? Between 10 and 20 is 15, yeah?
Yeah.
And between 20 and 30 is
25.
25. And between 30 and 40 the midpoint is
35.
35. And between 40 and 50 the middle value is 45. Okay, what is the mathematical way of working at the midpoint when the numbers are a bit more difficult? You average the two numbers, so 10 at 20 is 30, then divided by 2 gives you 15. 30 at 40 will give you 70, divided by 2 gives you 35. That's the other way of working out if you can't see it mentally in your head. That's the value. Now, what do we do next? We've got the midpoints, we've got the frequency, we have to... What do we do next? Times them. Right, off you go then. So we've got 5 times by 3, that will give you an answer of 15. Okay, we've got 15 times by 8, that will give you an answer of 120. Good. Okay. You got 25 times by 11, that gives you an answer of, Isa?
275.
275. And 35 times by 9 will give us an answer of?
315 or 25.
315, okay. Okay, so no idea for that one?
The last one, 400.
35 times by 9.
350.
Good. 45 times by 9.
405.
Okay, Isa, you got those numbers as well?
Yeah.
Right, what do we do now? Now that we've worked with the midpoints, we've multiplied it by the frequency, we have to add them up to give us a total. And don't forget also we've got to add the frequency as well. So we've got two totals. Well, the total of the frequency is given in the question. 40 friends. Right folks, can you make sure you give me the correct totals for that? Right, let's have a look, Mr. Isa.
Done.
Okay, hang on a second. Okay, Mr. Isa, and for me, what's your calculation?
I got 1,130.
Good. Okay. Isa, can you double check that please?
Yeah.
Right, so if you want to work out the mean, we have to get the sum of the midpoints times by the frequency, and we divide it by the sum of the frequencies. So that's the actual formula. That sigma sign is sum of. Okay? You normally see that sign in if you're doing statistics, GCSEs, or later on when you come across A levels as well. That's fine. Sigma, it's just a small sign. Means sum of. Have you worked out the sum of it?
Yeah.
Yes. What is the sum of the midpoint times by the frequencies? The answer is 1, 1.
30.
Okay. And what is the sum of the frequency? What's the total frequency? It is
40.
40. So you need to do that calculation to work out the mean. That will give you an estimate of the mean for a grouped frequency table.
28.25.
So you should get an answer of 28.25.
Yep.
That's lovely. So our mean approximately is 28.25 minutes. Okay. Is that okay, Isa? Your calculation? To me, is that okay?
Yep.
Good. Okay, let's stop this off and move on to the next question. I've got loads of questions left. Okay, expand and simplify. So we have. Isa, can you? Don't do this. Okay, I'm just going to write this bit big over here. Isa, can you see me in the frame?
Yeah.
Clearly? Can you see the text and stuff?
Yeah.
Okay, good. Now go and sit it back down. Thank you. Right, I've just copied out this equation bit over here. Expand and simplify. Right, first of all, when you have double brackets, we start at the first item over here, P. We multiply it by each item in the second bracket. So we say P times by P is the first calculation. Then we have P times by -4. Okay, so I'm going to color code this. Isa, you happy with that so far? Got that?
Yeah.
Then we go to the next item. The 9, we multiply that by each item. Remember that's plus 9. We're multiplying by p. We've got a plus 9. And we're multiplying by minus 4. So let's have a look. What do we get? So the first part, Samia, p times by p will give you
P squared.
p squared. Isa, p times by minus 4 will give you
Minus 4p.
minus 4p. Samia, plus 9 times by p will give us
Plus 9p.
plus 9p. Okay. Now, folks, I'm not copying out any symbols from the top in the sense that these minus hasn't come from there or that plus hasn't come from there. This plus has come from its own calculation. This minus has come from its own calculations. So make sure when you copy the numbers down, when you do the calculation, you consider the sign. So next part was plus 9 times by minus 4. So I've got plus 9 times by minus 4 from the calculation. That will give me a numerical answer with its own sign. So plus 9 times by minus 4 will give you a what?
Minus 36.
Minus 36. So we don't have a situation where we've got p squared and a gap, 4p and a gap, 9p and a gap with no symbols. The symbols come with the answer that as we're working it out. Now what do we do now? We need to simplify. So the p squared doesn't simplify, that stays as it is, because there's no other p squared. We have minus 4p and plus 9p. So you have 9p, you take away 4p, so how many p's do you have left over?
5p.
5p. Okay. And you have minus 36. Can that simplify with anything else? No, because that's the only numerical value there. So that'll give you p squared plus 5p minus 36. Okay, Isa, have you got that down? Can you please get that down for me, please, before we move the board up?
I've done that.
Done it? Okay, lovely, good. Okay. Right, the next question says solve. Oh, we got more. Okay, let's get rid of that then. Okay. Says solve 5w minus 8 divided by 3 equals 4w plus 2. You see, we've done quite a bit of work on algebraic fractions. What do we have here? We have a denominator, we have a fraction here, an item here 4w plus 2. What's the easiest way to get rid of the divide by 3? Opposite of dividing the left by 3 is to move it across. We call that cross multiplying. So I'm just going to write the question out again if you can't see the original one. Okay, the easiest way to get rid of the divide by 3 here, you get the divide by 3, you take it across to the other side and it becomes times by 3. So we now have 5w minus 8 equals 3 times by 4w plus 2. Now, Isa, can you remind us please, why have I got a bracket on the side? Why would I just park the 3? Why would I just put the 3 at the end or put the 3 at the front and let's left it there as a multiplier? Why put a bracket there? We got times? Correct. Opposite of dividing the left hand side by 3 is to times the right hand side. On the right hand side you have 2 items, so you multiply both items by 3. That's why the 3 times and the bracket is there. Now what do? We need to solve, work out the value of w. So what do we do next, Samia? We need to do this side on the right hand side. We need to multiply out the brackets. So we go for the multiply outside. So the 3 has to times by each item inside. So you have 3 times by 4w
12w.
is equal to 3 times by 4w is equal to 12w. Isa, 3 times by plus 2 will give you plus 6. And this side we just copy down. So what started off looking like quite a bit of a heady question, we got like a fraction on this side and no fraction on that side. Think, oh, for most students they look at that question and go, ooh, can't do this question, and they just go on to the next question in the examination. Nothing to worry about. Opposite divide by 3 is times by 3. That's all it is. So we've done that. We multiplied out the brackets. Now what we've got is a linear equation. We've got w's on both sides. What should we do? We've got w's on both sides. How do we solve it? We've got to get w's on one side. We always start with which w, the small one or the big one? the small one. We start with the small w, move it toward the big one, and then we get the numbers and we move that in the opposite direction. So w's on one side, numbers on the other side. So we now have 12w, opposite of plus 5w is minus 5w. Remember, this minus here does not belong to the 5w, it belongs to the 8. And then you have minus 8 here. Opposite of plus 6 Isa is minus 6. What's minus 8 minus 6? That will give you a total of
minus 14.
minus 14. And what's 12w minus 5w?
7w.
7w. Okay. Now, you okay with that so far, Isa?
Yeah.
Got that? Right now, we have to work out the value of w. We got 7w. So we have to remove the multiply by 7. Get rid of it. So we grab it, take the other side. Opposite time by 7 is
Divided by 7.
divided by 7. So now we have what we wanted is w on its own,
Equals
and
minus-
minus 14 divided by 7 gives you
It's 2.
minus 2. That is the solution. I'll give you a moment to get that. You got all that answer? All done? Happy with that?
Yeah.
Good. Okay, Isa's happy with that. Me happy with that?
Yeah.
Okay, right. I think we will move it up. Please. Okay, the next question says factorize x squared minus 49. Let's just write it out again, a bit bigger. Now, first of all, what type of special type of question is this? X squared minus 49 is it's called the difference of
2 squared.
two squares. Because x squared is a squared number, x squared. 49 is a squared number, it is really what in disguise?
What?
So 49 is really what number in disguise? 7 squared. Okay, thank you, Isa. So you have x squared minus 7 squared. If you don't spot that this is the difference of two squares, you will not be able to factorize it. Okay? I don't see how you can factorize x squared minus 49 unless you realize it's that particular special circumstance. Now, these factorize in a very nice and easy way. Okay, how do we do that? So, copy the x down, copy the minus down, copy the 7 down. Copy it down again, change the sign in the middle. When you have the difference of 2 squared, this is the format of the equation, and I'll give you a quick little. So algebraically, a squared minus b squared, when you factorize that, it gives you a minus b, which is the a copy down, the minus copy down, the b copy down, and then you duplicate the brackets, and when you have a minus, you put a plus. So that's a template, if you want to call it, like a formula. It's a standard way of doing that type of question.
Yeah.
Okay, so you don't need to work it out yourself. You just follow the template. If it's a squared minus b squared, the brackets will say a minus b, a plus b. That's it. You have to memorize that. Okay, go factorize that. Okay, the next question. Come on. Yeah. Just make it easier. Plus a bit. Plus it. You're just trying to bit more. Okay. Oh, that's very nice. Yeah. Okay, let's have a look at that. I think that one should. Oh, that's been wrong place. Is that better? Hang on a second. Yeah, that looks better. Okay, we just enlarged a bit. Right. It says simplify 9x, 9 times x to 8y3 to the power of a half. First of all, okay, let's put on before we forget, what is the index of 9? The index of 9 at the moment has no index on there, no power. If a number has no power, what is the power? 1. Thank you. Now, the rule states that when we have an index, when we have a number and its index, and we apply another index to it, we have to multiply them. We have now, because we got 1, 2 and 3 values in there, 3 items, we have to do that 3 times to make it correct. So we start with 9 to the power of 1, okay, and then we times that by a half, and then we have x to the power of 8, times that by a half. So when you raise a power to another power, you multiply the powers. You have y to the 3 times by a half. So each index 1, 8 and 3 has to be multiplied by the power that we're raising the powers to. So what's 1 times by a half? 1 times by a half is simply a half. 8 times by a half is going to give you, 8 times by a half will give you 4. 8 times by half, yeah? Give you 4. And then you have y times by, so you got 3 times by a half will give you 1.5. Now, I'm going to take the times out in the next part of the, just make sure it's all on there. Is that all on there? Now it says simplify. Now 9 to the power of half. What's a half power mean? Half power means it is a square root. Half power means square root. So we're going to get the 9 and we're going to square root it. And then we've got x to the 4, y to the 1.5. What's the square root of 9? Square root of 9 will give us 3. You can put it also as a decimal as well, that is also good. That is also acceptable as an answer. Okay. We can put 1.5 there, or this is also another way of writing it. Or use the original value that we had here, 3 times by half, it gives you 3 halves. Okay. Right? So don't worry if you use any one of those particular formats. Okay, done. Next question. Is everybody ready for the next question?
Yeah.
Right. I think we should enlarge it in the beginning. Okay. Question number 15. What time actually is this now?
45.
What time is it supposed to go? Okay, Henry's thinking about having a water meter. Let's make that slightly smaller and take it up a bit. You can. That's it. Okay. Henry's thinking about having a water meter. I hope it's not horrid, Henry. Okay. Yeah, we can see that nice and clearly there. Alright, let's see if we can see. Where's the little light one? Okay, a bit of extra light there. Right, Henry's thinking about having a water meter. These are the 2 ways he can pay for the water meter, the water he uses. This is the water meter technique. We have a charge per year plus 91.22p for every cubic meter water he uses. And if he has a no water meter, he pays a fixed charge of £107 per year. Okay, you happy with that? That's the basic question. Because Henry uses an average of 180 litres of water each day. Okay, let's get started. Okay folks, we had this is part 2 of the same paper. We got it's the June 2012 paper, Edexcel 1 MAO. Okay, it's the second paper. Alright, now this is part 2. Starts from here, question number 15. Bismillahirrahmanirrahim. Okay, that was the end of the first video. Right, welcome back. Henry's thinking about having a water meter. These are the 2 ways he can pay for the water he uses. One is using a water meter with a £28.20 fixed charge plus a charge per cubic meter. The other technique is no water meter and a charge of £107 per year. Well, that one, there's nothing really to work out there. That's what he's given. Because Henry uses an average of 180 litres of water each day. So let's have a look. 180 litres, how many days do we have in a week?
7.
365 days in a 365 days in a week. Okay, 6 days in a year. Okay, so he's using 180 litres per day. We have 365 days in each year. So let's work out total quickly on the calculator. Come on, Isa, give me the answer for this. So 180 litres times by 365 days a year will give us a total of
65700.
65700. That's litres, yeah? Okay, that's how many litres he's using per annum. Okay, now we need to work out, we need to convert those litres into cubic meters. Okay, so now we need to get this number here and we have to divide it by 1000. Okay, right. If we divide it by 1000, what do we get? Quickly.
65.7.
65.7, and that will give us what? Cubic meters. Right, now, what is the charge per cubic meter? The charge per cubic meter is 91.22 pence. So we need to get that value there now. So 65.7 times by 91.22. Now remember, this is the unit charge in pence, isn't it? In pence. If you want to change into pounds, you have to divide the answer by 100 to convert the answer into pounds. So can you do the calculation for me now, please? 65.7 times by 91.22 and then divided by 100. Okay, question number 15. Come on, Isa, give me some solutions, please. Okay.
I got 59.93154.
Okay, what do you guess, Mia?
59.93154.
So we had 65.7 meters cubed. We times that by 91.22 and then we're going to divide it by 100 and that gives an answer of
59.93154.
Okay. What's the answer, Mia? 59 pounds.
Pounds 93154.
154. Okay, let's just say it's 59 pound and 93. Okay, and then what are we going to add to that? The fixed charge. So that's how much the water cost. That is the fixed charge. Can you add them up for me, please? So you have 59, that plus the 28 pound 20, and that will give you a total of
£88.13.
So the total there is £88.13, and so we've worked out how much the water cost us and how much the yearly charge is. That gives a total charge of £88.13. So which one is cheaper? The one with the water meter, the one with the no water meter? Which is our conclusion, Isa? So which one is the cheapest way? The first way, the one we just calculated, or the second way?
First.
The first way. So we should get a. So Henry, what should have? Should he have? The answer is yes. Water meter, please. Okay. Right. Have you got that down first of all, folks? Yeah. Can we rub that off and go on to the next page? Yeah.
Yeah.
So remember the star next to it. That's going to be our functional skills question. You said we got all that down?
Yeah.
Good. Okay, next question. Let's double check. We got that all in focus. It's looking beautiful. Alright. So here we have a right angle triangle, question number 16. We've got to work out the angle here. in this right angle triangle. Right angle triangle, straight away you should be thinking about trigonometry, Sokotowa, because we've got to work out the angle. Right, let's write this down. Okay, what I would like to do first of all, what do we do with the diagram always? We always have to label the diagram. So the side which is opposite the angle is called the side which is opposite the angle is called the opposite. Okay? Yeah? So this is called the opposite side, the O. Now, the side which is opposite the right angle, that is always called the hypotenuse, which we label as H. So that leaves us one side that hasn't been labelled. What do we call that side?
Adjacent.
The adjacent, which we're going to label as A. Now, if we look in this particular question, the information that we have is A and H. Now, what sound does the A and the H make?
Cat.
The A and the H makes ka sound. Ah. Okay, the A and the H makes an ah sound. And the ah sound is in cos, because cos is ka. Okay? So we know the A, we know the H, we just don't know the actual angle. So we use the cos identity. Now, when we use the cos identity, we need to cover up the thing that we're looking for, what we need. So we use, so I don't say use your thumb. So if you use your thumb on the C, what's left behind? So the cos of the angle, if you cover up the thumb, cover up the cos, it leaves you behind with A divided by
H.
A divided by H. Okay, now, do we want to work out the angle or cos of the angle? We want to work out the angle. So what do we do with the cos part?
Take to the other side.
Take the other side. Now cos is the function, so the opposite of cos is
Cos inverse.
inverse cos. Okay, now we are ready to substitute our values, okay? Okay, Isa?
Yeah.
So theta equals cos minus 1 A over H. Okay, right, let's have a look. What's my A value? My A value is 6.4. My H value is 9.6. Okay, to get the cos minus 1 function, what do? We have to get shift cos. So Samir, what do you get for that one?
I got 48.1896,851.
Okay, wow.
So 48.189.
Right, 48.189. Okay, the question says here, Isa, that they want us to give the question to what? How many decimal places?
1.
1 decimal place. If you put this down as your answer, you'll get it wrong. You'll lose a mark here. Because I've got 3 decimal places, I haven't finished yet. So the final answer is going to be, put over here. So theta is equal to, put the answer down here. 48.2. So the answer should be 48.2. Okay, that is lovely. We are now ready to move on to the next question. Samia, can you move us up on to the next question, please? Is it got the done? Okay, right, Liam invests £6,200 for 3 years in a savings account. He gets 2.5% per annum compound interest. Compound interest has a different type of formula. How much money will Liam have in his savings account at the end of 3 years? Okay, first of all, we start with our principal amount, 6,200. That's our principal. Okay, now, if something is going up by 2.5%, let's have a look. 2.5%. So we first of all will start with 100%. That's the original value, which is that. we're going to add onto it 2.5%. Is what will give us
102.
102.5. Okay, now if you want to change that into a decimal, 102.5%, what do we do? To change a percentage into decimal, we divide it by 100. That gives you, there's our multiplier. So the principal there's your principal amount. That will work for 1 year. So the 1 year will tell you that you increase your money by the original amount plus the extra bit, which is 2.5%. That's what the 2.5% means. Now it says that it's done it for how many years? 3 years. So we're going to do this. We're going to get 6,200 times it by the 2.5% increase, and we're going to do that 3 times again. So times it by this, and then again by that, and then again. And the easy way of doing that is cube it. We're not multiplying it by 3, we're cubing because we're multiplying it by the same number again and again and again. Right. Just for the moment. So this will be your answer for this. Can you give me an answer, please, Mia?
667.6.
667.6.72.
72.
Is that it?
1875.
Okay. Right. Are we happy to say the answer will be 6,672 £76 and 72 pence? Yes. 667. Okay. Why have I stopped the question at 2 decimal places?
Because it's pence.
Because it's pence. Okay. Lovely. Okay, Smia, are we ready? Are we ready for the next one?
Yeah.
Okay. Get that answer, Smia?
Yeah.
Okay, is it nice and big? No, that's lovely, nice and big. Okay, the diagram shows the quadrilateral ABCD. ABCD. Quadrilateral means 4-sided shape. It's given us some measurements on there. As we can see here, we've got the right angle triangle, another right angle triangle. So right angle triangles indicate one of 2 things. We're going to use Pythagoras theorem or trigonometry or both in this question. Okay? Because the right angle triangle, that's where we focus on those 2 particular parts of mathematics. Now it goes calculate the length of CD. Well, CD is going to be this length over here. So we got to work out CD. Now, in this right angle triangle, what do we know? In the top one. In this right angle triangle over here, we only know the angle and we don't know anything else. In order for us to use trigonometry, we're going to have 2 items that we know and 1 that we don't know. So at the moment we don't know lots of things. We just know 1 item. We need to work out, what should we work out, Isa?
That one.
That length there. If we work out BD, if you have a length and an angle, we can then work out another length. Okay, 2 ticks and a cross technique. So let's see if we can work this side out first. Now I'm gonna look at this smaller triangle here. This smaller triangle here, I'm gonna take this off here. We have our hypotenuse, because opposite right angles is hypotenuse. Now let's look at Pythagoras theorem. This is the Pythagoras theorem, comes in lots of different guises. It comes in like this: a squared is equal to b squared and c squared. It comes in a squared plus b squared is equal to c squared. Comes in different variations depending on who teaches you, which book they're using in school. I have my own version. Okay, so let's look at the way I would explain it to you. The hypotenuse squared is equal to, okay, we have b squared plus c squared. Because whatever you have out here must be the hypotenuse. So our hypotenuse is 16. So 16 squared is equal to the other 2. B and C are the other 2 lengths in any order, it doesn't matter. So I'm just going to call this one here B and call this one here little c for my triangle. Okay, I'm going to ignore this here and this here. Okay, so we have our triangle here. I'm going to go over it. Okay. So what is the value of B, Isa? The value of B is
12.
12. And the value of C is what we need. Let's call that C. Okay, now we have to work out C. We know this, we know this. So we need to get this part here. Opposite of adding this onto that is to minus it. So 16 squared minus 12 squared is equal to C squared. We're getting closer. Isa, do we need the squared on the C?
No.
No. So we grab the square, we take the squared over. The square becomes a square root. Just make sure that's actually in the video. We're not missing any parts off. Okay. That becomes a square root. Okay. Now, let's work it out now. Let's just write it out one more time on the bottom, make it nice and clear. Okay, Mr. Isa, have you worked that out on your calculator?
Oh.
Okay, I'm going to give you a moment to work that out, please, folks. Okay, done?
Yeah.
Right. What do you get, Isa?
10.583000524.
Okay, we get 10.580.
It's 10.583.
Okay, 10.583. Now, it says give your answer correct to three significant figures. Let's write down here 10.583. Remember what we said before, your first significant figure is your first non-zero digit, which is 1, second, third. So we have to stop here. This we call this the last digit. This one here, we call this one the decider. Okay, now, the decider, if it's 5 or more, we add 1. And in this case, that's 8, add 1. 10.6, 10.6 centimeters is C. Are we happy with that, folks? We got 10.6 centimeters for the first part. Yeah. Right. Now at the moment, it goes to calculate the length of CD. I think what we've done here, we've rendered this value to three significant. That's not the answer yet. Okay, let's go back one step. 10.583 is just our first part calculation. We have to round off the last value, okay, by three significant figures. So what we've done here, the rounding part that we've done here, some students, when each time they get a number, a value, they start rounding it off. Don't round it off. So what we've just done here, the rounding part, that's an example of when you can start truncate that number. When you're going to feed this number back into the next part of the question, we're going to start getting rounding errors. So let's keep this number as pure as possible. So that rounding part there is an example of what not to do at this stage. Let's now move on to the second part of the question, which is working out the length CD, BC. Okay. So we've got to work out this length over here now. Let's have a look at the triangle. So we have now, we've got 40 degrees over here. This length here we just worked out to be 10.583 something something something. Okay, now, are we now in a situation where we can work out this length? We need to work out this length here, C and D. So we have here a right angle triangle, we know one angle, we know one length, so we know, yeah, we know two items, and we've got to work out this length over here. So the first thing that we do in this triangle, we need to label it up. So opposite the angle is the opposite. Opposite the right angle is the hypotenuse. Okay? Right. Okay. Right. So in this question here, we know the opposite. We don't know the hypotenuse, but we do know the angle. Right, let's look at our Sokoto again. So if we have a question, we're working O and H, you have to think about how O and H, O, O. So which one do you go for, Sokoto? Which one do you go for? So. If you've got an OH sound, we'll be using so of the Sokoto. Okay, so let's have a look. Okay, so we will be using the sign. Okay, the sign. Now, what do we know? Let's have a look. We know the opposite ticket, we know the angle ticket, and we don't know the hypotenuse cosec. So cover this up with our finger. That's our finger covering over here. So the H will then give us an answer. So the hypotenuse will give us opposite divided by the sine of the angle. So cover up with the thumb. Hypotenuse equals O divided by S, the angle. So the opposite is equal to what? 10.583. Okay, and then we have to do divided by the sine of 40. Okay, and that gives you the H, which is equal to CD. Okay, let's put that into calculators, please, folks. 10.583 divided by sine 40. And that will give us an answer of
16.464.
16.464. This is the number here that we need to round to three significant figures, not the first value you had. That was part way through a question. Okay? So that part there was showing you if we did that, then you would start rounding of numbers. Most students do. They round off each number. Don't round off each number. Try to use the pure values all the way through. You round off just this answer here. Yeah. So if you round this one off to three significant figures, first, second, third significant figure, that's the last digit. That one is your decider. It's 5 or more, add 1. So that will give you an answer of 16.5 centimeters is equal to CD. Got that? Finished? Okay.
Done. Write it there.
Yep. Copy all that down. Done. Don't forget to write down centimeters though. Extra.
Yeah, it's ready.
It's already there.
It's already there. Okay. Okay. I can't see that on my board. Right, let's move, folks. Okay, number 19. I think we're going to do one or two more questions. How many questions have I left to me on the paper?
We've got 1, 2, 3.
Okay, a few questions.
8 questions left.
Okay, I think we're gonna do this question and we're gonna have a break, and then we're gonna come back in video number 3 to do the next part. Okay, p squared is equal to x minus y divided by xy. Find the value of p. Okay, So in this calculation here, if we want to work out the value of p, first of all we got to take the square and take that over. Opposite squaring is, so p will then be equal to x minus y divided by x times by y and square rooted. Now this is why we're going to be careful in your calculator. So in the calculator you're going to put in, use the fractions button first, 8.5 times by 10 to the 9 minus the y value, and then we divide it by xy again. So the x value will be okay. You need to enter this into your calculators. I'm doing this. Right. First we use the fraction button in the calculator, then enter this and use replay code bottom and then square root it. Right, come on. Let's see what you get. I'm going to try as well. Square root, fraction button, 8.5, 10 to the 9, take away 4, xp, 8, 8.5, 10 to the 9.
I'll get 0.
Okay. You shouldn't get 0. Yeah, you gotta put brackets there because it'll confuse the time bar for something else.
I got 0 as well.
Yeah. Okay, folks. Now, in the calculator, when you put the calculation, you gotta put brackets here to separate them two. Otherwise, you'll get 0. Now try it. Go back and try with the brackets. You should get. The answer I always got. My answer here is 4.880935. Okay, and it goes give you answer to two significant figures, first, second. So that's 5 and more, you add 1. So the answer should be 4.9 times by 10 to the power of minus 5. Are you happy with that? Yes, sir. Have you got a better answer now that you put brackets in there? The calculator will get confused the time by 4 and with the index. Done? You got the answer? Okay. Well done to me, you got the answer. That's lovely. Okay. You got the answer?
Yeah, 0.
So you and 0, 0. Okay, Mr. Isa's again. Where's calculation? Why is it open here? Oh, why is it floating? See, you like you got an index there.
I'm supposed to press it twice.
So bring it back down. Okay, try that again. Okay, I'm move the question. Smell, what's question number 20? Okay, we're going to stop at question number 20, so that's going to be the last one. I think everybody has had enough. Question number 20, well done, Smia. It says, make T the subject of the formula. Now, if you look at this question here, to realize we have a T here and a T there. It's still a linear equation. We've got T's on both sides. What we need to do first of all is to insert this t from the brackets, and then get the t's on one side, factorize it, and then solve it. So, first of all, let's release the t. So 2 times by d is 2d. 2 times by minus t is minus 2t. And the 4t plus 7 stays the same. Now, if you look again, now that the t has been released, we have a t value here and one here. We always move the smaller t value towards the larger one. So I'm going to grab the minus 2t from here, which is smaller than 4t. Go that way. And then we're going to get the plus 7 value from the right hand side and move it towards this way. So that way we'll get all the t's on one side. So we have now 4t plus 2t. We have now here 2d minus 7. Okay, if we've got here now 4t add 2t, that will give us a total of, Samir? 6t. Now, yeah, and the opposite of time by 6 lots of t is 2. So that's one way. That's the traditional way. I'm going to do it the way I've been doing it so far. Opposite time by 6 is? Divide by 6. Okay, and that's question number 20. Now that is going to be the end of video 2. Okay, please join us again, inshallah, for video 3, where we will finish up the last questions. Okay, and until that time, inshallah, see you then. Assalamu alaikum. Okay, it's me. Right.